Hi, Ms. Baddick. I'm doing this project with Regina and Wynn from your sixth period, and we're going to be talking about how oil affects the ocean. We split it into 3 sections so that it would be easier for you to see it.
The lab we chose to do is Blobs in a bottle. We linked it here for you to see. The purpose of the lab is to demonstrate how differences in density and polarity will cause liquids to react.
These are the materials that we used for our lab. We used one clean 500 milliliter soda bottle, half a cup of water, vegetable oil, fizzing tablets, red food coloring, and a measuring cup. As for the safety precautions, all of the materials that we used were non-toxic and safe. We used a measuring cup to ensure that the measurements were accurate and that no vegetable oil would be spilled on me or the countertops. I also tied my hair up to ensure that nothing would get knocked over or my hair wouldn't get inside of the water or the vegetable oil. And this is our procedure, but I will explain it as we watch the video. So this is me, and I was on a call with Regina so that she could see what we were doing, and those are our materials. And I had pre-measured half a cup of water in a separate glass, and I'm pouring it into our bottle here. I spilled a little bit, but measurements in this lab are not accurate as they do not affect the results. So I have vegetable oil, and I'm pouring it into a measuring cup to make sure that none of the oil spills on my hands or onto the countertops. Like I said earlier, the measurements of the vegetable oil are not important. So I just poured it in until we reached the top of the bottle. And I did not have enough oil, so I had to pour a little bit more into my measuring cup. And so we neared the top of the bottle, but we left room for some air. And almost immediately, the water and the oil separated, and here I'm showing that. And we added 10 drops of red food coloring to show the bubbles that will occur or that will form later. And at first, when we dropped the food coloring in, it wasn't obvious that there was food coloring in there. It didn't turn pink or red, but as soon as we add the tablets, it would show. So here are my fizzing tablets, and we just broke one in half. Yep, and we dropped it in. And as soon as I dropped the tablet in, bubbles started to form, and the red color started to come about. And as you can see, the bubbles are zooming to the top. And yep, here we see the bubbles going to the top. And it started to calm down, so I added some more of the fizzing tablets to show what we just saw. So that was our blobs in a bottle experiment. And so when we poured the vegetable oil into the water, the 2 liquids almost immediately separated, and I showed the line at which they met. The oil was on top, and the water sat at the bottom of the bottle. And after adding 10 drops of red food coloring, the color did not show, but the red color did begin to appear after we added the tablets. When the tablets were dropped into the bottle, bubbles immediately started to sprout from the bottom to the top of the bottle, and the gases went out into the little air pocket that was there.
We will begin to discuss several topics we chose now. What happened in the lab? When we poured the vegetable oil inside of the water bottle, the oil remained above the water. This is due to the fact that water is more dense than the vegetable oil. In addition, intermolecular polarity, which is drastically different from molecular polarity, causes the 2 liquids to not mix together. Molecular polarity causes the water molecules to be attracted to other water molecules in the solution. Likewise, the oil molecules will be attracted to the different oil molecules as well. This is when intermolecular polarity comes into action because the molecules are unable to easily bond due to their structures. Then, food coloring was added, but the color was not visible until the fizzing tablet was included. When we dropped the fizzing tablet, it began to dissolve and a gas was created when it sank to the bottom. Gas bubbles started to rise afterwards, which caused the gas bubbles to take a bit of the colored water. Finally, the colored water floats up to the top. The oil became less dense than the remaining gas and water when the bubbles popped. These changes in density caused the water to go back down when the gas escapes from it.
The issue that we were able to connect to our experiment were oil spills. Oil spills can occur due to both human error and natural disasters. They occur when people make mistakes, or when equipment breaks down, or when hurricanes or strong winds occur, or even when other countries deliberately dump oil into other countries' oceans as an act of vandalism. In the United States alone, about 1.3 million gallons of oil are spilled every year. And the experiment that we demonstrated showed that oil floats on water due to the difference in density. In the ocean, oil continues to thin until it becomes something known as oil slick. And the oil continues to thin until it becomes a sheen and looks like a rainbow sitting on top of the ocean surface. Oil spills are extremely dangerous to marine life and can even harm the health of humans who consume
The
seafood.
effects on marine life. Marine life is significantly affected by oil. For example, when an animal comes into contact with oil, it will attempt to ingest the toxicity of the liquid. Marine mammals, like seabirds and sea otters, are most affected by oil spills due to various reasons. In specific, these animals spend their time on the surface of the ocean where the oil could possibly come ashore. Compared to the other types of animal species, seabirds are most harmed from oil spills alongside sea otters. For instance, a sea otter's ability to stay warm is lost if its fur is not clean. Other creatures, specifically terrestrial animals, could possibly be killed if the oil stays on the beach for a long period of time. Marine mammals that do not have heavy hair coats face the same issues as well. Ingestion and skin exposure to oil will cause the animals to obtain organ failure alongside altered body temperatures. In addition, microorganisms and many species of fish are not insensitive to oil exposure. According to the Washington State Department of Ecology, half of the Dungeness crab larvae will be killed when a gallon of oil is spilled into the ocean.
Oil spills not only affect marine life, they also affect human life. Oils in the ocean create medical issues for both marine life and can put human health at risk. Responders who clean up oil spills or save animal lives are at risk of skin and eye irritation, neurologic and breathing problems, and even stress. Oil spilled in rivers can also contaminate the drinking water that everyday people like you and me drink. Um, Oil spills also affect the reproductive systems of fish and shellfish, and commercially important species like oysters, shrimp, and different types of fish could be too contaminated to be safely caught and consumed, and therefore negatively affecting the fishery industry. Unfortunately, oil spills are relatively common in the US, and we have local, state, and federal government agencies, as well as volunteer organizations who respond to these spills. There are many different methods of removing spilled oil, including the use of booms or floating barriers that collect the oil, skimmers, boats that skim the ocean surface to collect oil, sorbents or huge sponges that absorb oil, and chemicals that break oil down into its chemical components. We also use vacuum trucks that vacuum spilled oil off the ocean surface. Many private organizations cooperate to save the lives of animals who may have been injured in a contaminated area. They put effort into containing the spread of the oil, keeping animals away from affected areas, and providing medical help for any injured animals.
Finally, we will discuss the conclusion of our lab. In our blob in a bottle experiment, we observed how the differences in density caused oil to float on the surface of water. Similarly, industrial oil often spills and sits on the surface of the ocean, harming both human and sea life. Unfortunately, oil spills are still very common in the US. Luckily, there are many organizations that care for and protect marine life from tragic oil accidents. We chose to research this topic because we were interested in learning about how organizations go about their rescues. Although we were previously knowledgeable about the effects that oil had on sea life, we were not aware of the risks that humans face as well at all. This is definitely a noteworthy learning experience outside of our typical lab environment.
These are the citations that we use throughout to get our information. The first one is the link to the lab. The rest are in order according to slides. And thank you for listening to our presentation, Ms. Baddick. We hope you have a nice summer.